Hello friends, today's discussion is about Kelvin's bridge. As earlier we have already discussed about Wheatstone bridge. The range of resistance that can be measured by the Wheatstone bridge is about few ohms to mega ohms. Now the condition in which you have to measure a resistance of less than 1 ohm, you go for Kelvin's bridge. So that's low resistance category. Now the examples for like measuring a low resistance is the resistance of the ammeter, which will be very negligibly low to prevent the drop across the meter during the measurement. So basically our unknown resistance which we will be connecting is most probably an ammeter. Now let's see what are the principle of Kelvin's bridge. See, actually, as we already discussed, it's a modified version of the Wheatstone's bridge. Okay, fine. Now we were discussing about the Wheatstone's bridge, and the ratio P by Q equal to R by S is called null deflection point, wherein the potential at VB and VD is equal. But when we are measuring a smaller resistance value, the issue is that the lead that connects between the resistors, suppose R and S, the lead between these resistors have small value. So this can cause an error in the measurement, and the condition in which the galvanometer can read a small value of current. So which means there is an error in the measurement of the actual resistance, unknown resistance R. So in that case, we go for a alteration or modification in the Wheatstone bridge by using a similar connection wherein we studied about the potentiometer using a jockey and a wire. So here we could see the terminal M and N in the figure. So this is a wire connected between M and N. Now using a jockey and a wire, you are connecting the galvanometer onto the wire. So when we move the jockey in between the terminal M and N, the resistance R1 and R2 are formed in between the point MD and DN respectively. So if we maintain the condition R1 by R2 equal to P by Q, then we will get, after a number of calculations and analysis, we are able to prove that we will get the ratio R by S is equal to P by Q, which is that's how we could measure the unknown resistance R equal to P by Q into S. Now let's see the circuit setup for Kelvin's bridge. Here you could see a DC voltage source similar to the Wheatstone bridge connected through a 40 ohm 10 ampere rheostat and a 5 ampere ammeter. Now here we have the galvanometer in series with the 1080 ohm rheostat, which is connected at this terminal, galvanometer terminal. Now here is the unknown resistance connected between the point C, which is short with P. There are polarities over there, you should be concerned about it. And this is how you connect the ammeter across this point. Now this is a switch, KA, KB is a switch. So on connecting this or on closing this switch, you can see the galvanometer getting reflected. So this is a knob. So it similar to that we discussed in the Wheatstone bridge. Initially we will be putting in the minimum condition. Now the range selector like P by Q is also available in this setup. Here you have two connections. One is direct connection, wherein the positive is connected to, similarly here the positive will be connected at this point, negative will be connected at point C. Now we will go, if we go for reverse connection, this EMF polarity will be interchanged. So that is D and R knob. So initially we will be putting into direct mode. Position of current switch will be in direct for one set of experiment. Then after that we will be switching into reverse mode for second set of experiment, but the procedure will be same for each set. Now the knobs are put into minimum position This is very for minute measurement, and this is for a greater range of measurement. Anyway, we start to we start to increase the step of this bigger knob with a greater multiplier, and similar at the same time we will close the switch KA KB each time, and we go for watching the galvanometer deflection as in the Wheatstone bridge, and the point at which the galvanometer needle get to cross the zero, we again switch back and start to step in the knob with 0.001 deflection, and we will bring the galvanometer unto completely zero. This is one set of experiment. The set experiment is again repeated, putting in reverse mode. So we'll be noting the dial readings in the tabular column shown, and this experiment can be repeated for different range from 100 to 1000, and in the both direct mode and reverse mode, and taking the average will give you the mean value or average value of the whole resistance. And this is how you conduct the Kelvin bridge experiment. Hope you understood the experiment. Thank you.